Children, in today's class, we are going to discuss the first unit metallurgy. To strengthen the fundamentals of the subject, bridge course was conducted for the past 15 days. I hope everyone utilized the class and improved your subject knowledge. In this lesson, we are going to see the introduction, occurrence of metals, minerals and ores, various steps involved in metallurgical process, thermodynamic principle of metallurgy, and applications of metals. Now we are going to see the introduction of the lesson. Metallurgy. Metallurgy relate to the science and technology of metals. Yes, metallurgy relate to the science and technology of metals. That is, metallurgy is the science of obtaining pure metals. Metallurgy is the science of obtaining pure metals. Importance of metals. We know metals are used in different ways. For example, metals like gold, silver, platinum are used for making ornaments and articles. Copper and aluminium are used as conductors and for making utensils. Then metals like iron, chromium, manganese, nickel, etc. are used for preparing alloys. So, we should know how these metals occur in nature and their extraction from their ores. Metals are found in the earth crust in the form of minerals. Metals found in the earth crust in the form of minerals. In the minerals, the metals may occur in the free state or in the combined state. In the minerals, the metals may occur in their native state, that is free state, or in the combined state. Only few metals occur in their native state. All other metals occur in a combined state. In the form of combined state, the metals occur as their oxides, sulfides, sulfates, carbonates, silicates, phosphates, etc. The metals are extracted from their ores by metallurgical process. Metals are extracted from their ores by metallurgical process. The extraction of pure metals from their natural sources is linked to the history of human civilization. The extraction of pure metals from their natural sources is linked to the history of human civilization. Ancient people used the available materials in their environment, which includes fire and metals, and they were limited to the metals available on the earth's surface. Due to the development of science and technology, we use a wide range of metals in our daily life. To minimize the waste and maximize energy efficiency, it is essential to design an eco-friendly metallurgical process. Yes, to minimize the waste and maximize energy efficiency, it is essential to design an eco-friendly metallurgical process. Such advances in metallurgy is vital for the economic and technical progress in the current era. The next we are going to see occurrence of metals. Just now only we saw metals are found in the earth crust in the free state or in the combined state. Before we are going to see the occurrence of metals in detail, just we can recall the properties of metals. About the properties of metal, you had been studied in lower classes. We know metals are in the solid form except mercury. It is a liquid metal. Then metals possesses shining appearance. They have high melting and boiling point. They are good conductors of both heat and electricity. They are malleable and ductile. They can be used for the preparation of alloys. Isn't it? Yes, these are all the properties that had been studied in lower classes. Now we can see the occurrence of metals in details. Metals are present in the earth crust in the form of minerals. In the minerals, the metals occur in the native state or in the combined state. Most of the metals are found in nature as compounds with different properties. Metals having least chemical reactivity such as copper, silver, gold and platinum occur in significant amounts as native elements. Yes, metals having least chemical reactivity such as copper, silver, gold and platinum occur in significant amounts as native elements. So these metals are called as native ores. So what are native ores? Metals having least chemical reactivity such as copper, silver, gold and platinum are called native ores or native elements. One of them possible 2 mark question. Okay children. Then reactive metals like alkali metals, alkaline earth metals occurs in their combined state. Yes, reactive metals such as alkali metals, alkaline earth metals, generally reactive metals, understand children, occurs in their combined state and are extracted using suitable metallurgical process. So remember all of you, least chemical reactivity metals occur in the free state in significant amount. Reactive metals occurs in their combined state. That's all about occurrence of metals. Then next we are going to see about minerals and ores. We know minerals are found in the earth crust. It may contains metal in the free state or in the combined state. In the combined state, the metals occur as their sulfides, sulfates, oxides, carbonates, etc. and obtained by mining. So, what is a mineral? A naturally occurring substance obtained by mining which contains the metal in free state or in the form of compounds like oxides, sulfides, etc. is called a mineral. Yes, what is a mineral? A naturally occurring substance. Remember children, minerals means naturally occurring substance. Understand? So, a naturally occurring substance obtained by mining which contains the metal in free state or in the form of compounds like oxides, sulfides, etc. is called a mineral. In most of the minerals, the metal of interest, that is the metal, is present only in small amounts and some of them contains a reasonable percentage of metal. Yes, in most of the minerals, the metal of interest is present only in small amounts and some of them contains a reasonable percentage of metal. For example, iron is present in around 800 minerals, but the minerals like hematite, magnetite, etc., containing a high percentage of iron are commonly used for the extraction of iron. Yes, minerals like hematite, magnetite, etc., containing high percentage of iron are commonly used for the extraction of iron. Then next we are going to see about ores. Minerals that contains a high percentage of metal from which it can be. Here it refers metal. Understand children? So minerals that contains a high percentage of metal from which it can be extracted conveniently and economically are called ores. Yes, what are ores? Minerals that contains a high percentage of metal from which it can be extracted conveniently and economically are called ores. For example, bauxite and china clay are the two important minerals of aluminium. Yes, bauxite and china clay are the two important minerals of aluminium. But aluminium can be profitably extracted only from bauxite and not from china clay. Understand children? The formula of bauxite is Al2O3 dot N number of H2O. The formula of china clay is Al2O3 dot SiO2 dot 2H2O. Understand? The formula of bauxite is Al2O3 dot N number of H2O. The formula of china clay is Al2O3 dot SiO2 dot 2H2O. Understand children? Yes. Bauxite and china clay are the two important minerals of aluminium. Aluminium is profitably extracted from bauxite and not from china clay. So, bauxite is the ore of aluminium and china clay is a mineral. Understand ma? Bauxite is the ore of aluminium and china clay is the mineral of aluminium. Understand? Yes. Hence, we can say all ores are minerals, but all minerals are not ores. Yes. What is the code word here? All ores are minerals, but all minerals are not ores. The difference between mineral and ore, an important 3-mark question. Yes, or write the difference between minerals and ores with example. Once again, we can see the definition of minerals and ore with example. Mineral, a naturally occurring substance obtained by mining which contains the metal in free state or in the form of compounds like oxides, sulfides, etc. is called a mineral. Ores, minerals that contains a high percentage of metal from which it can be extracted conveniently and economically are called ores. For example, bauxite and china clay are the two important minerals of aluminium. Aluminium is profitably extracted from bauxite and not from china clay. So, bauxite is the ore of aluminium and china clay is a mineral. Understand ma? Yes. Then next we are going to see the various steps involved in metallurgical process. There is various steps involved in the extraction of metals from their ores. Generally, metals are extracted from their important ores. So, the ores used for the extraction of metals should be in the pure form. Understand ma? Because the ores are found in the earth crust. Okay, yes, it may contains rocky material, siliceous matter as impurity. Understand children? Yes, so the ores used for the extraction of metals should be in the pure form. So the ores are first subjected to purification. The purification of ore is called as concentration of the ore. Understand children? So the first step of the metallurgical process is concentration of the ore. After purification of ore, the metal is extracted from the purified ore. Understand children? Yes. But the metal extracted from the purified ore will be in the impure form. So second step is the extraction of crude metal. Crude metal means impure metal. Understand? So what is the second step of metallurgical process? Extraction of crude metal. Since the metal extracted from the concentrated ore is in the impure state, yes, the impure metal, that is the crude metal, should be subjected to purification. The purification of crude metal is called refining of crude metal. So the third step of the metallurgical process is refining of crude metal. Understand? Yes. So generally three steps are involved in the extraction of metals from their ores. Yes. What are the various steps involved in the extraction of metals from their ores? Yes. The first step is concentration of the ore. Second step is extraction of crude metal. And the third step is refining of crude metal. An important 2-mark question. That is, write the various steps involved in the extraction of metals from their ores. Yes, once again we can recall the three main steps of the metallurgical process. Yes, what are the concentration of the ore, extraction of crude metal, refining of crude metal. Now we are going to see important ores of some metals. The important ores of metals are given in the form of table. From the ore table, you will be asked 1-mark and 2-mark questions. So all of you must thorough the ore table. First, we are going to see the important ores of aluminium. Aluminium. The symbol of aluminium is Al. The important ores of aluminium are bauxite, diaspore, kaolinite. Yes, the important ores of aluminium are bauxite, diaspore, kaolinite. Bauxite, it is the oxide ore of aluminium, we know. Diaspore, it is also an oxide ore of aluminium only. Understand children? Yes. The formula of bauxite ore is Al2O3 dot N number of H2O. The formula of bauxite ore is Al2O3 dot N number of H2O. The formula of diaspore is Al2O3 dot 1 number 1. Okay, 1 H2O. What's the formula of diaspore? Al2O3 dot 1 H2O. Understand ma? Yes. Then next we can see the chemical formula of kaolinite. The formula of kaolinite is Al2Si2O5 OH 4 times. Yes, what's the formula of kaolinite? Al2Si2O5 OH 4 times. Thorough all the 3 O's of aluminum. The first 2 O's of aluminum, that is bauxite and diaspore, are important. Understand ma? Yes. Then next we are going to see the important O's of iron. The symbol of iron is Fe. The important ores are hematite, magnetite, siderite, iron pyrite and limonite. Yes, the important ores of iron are hematite, magnetite, siderite, iron pyrite, limonite. Hematite and magnetite are the oxide ore of iron. Yes, remember all of you, hematite and magnetite are the oxide ore of iron. The formula of hematite ore is Fe2O3, whereas the formula of magnetite ore is Fe3O4. Understand ma? Yes, the formula of hematite ore is Fe2O3, whereas the formula of magnetite ore is Fe3O4. Then siderite, it is the carbonate ore of iron. So the formula of siderite ore is FeCO3. What's the formula of siderite ore? FeCO3. Then iron pyrite, it is the sulfide ore of iron. Understand ma? Yes, iron pyrite is the sulfide ore of iron. The formula of iron pyrite is FeS2. Yes, the formula of iron pyrite is FeS2. Then limonite. Okay, limonite is the hydrated iron oxide ore. Yes, limonite is the hydrated iron oxide ore. So what is the formula of limonite? Means Fe2O3.3H2O. Yes, the formula of limonite ore is Fe2O3.3H2O. Understand children? All the 5 ores of iron are important. So all of you must thorough the name and formula of all the 5 ores of iron. Understand? Okay, yes. Then next we are going to see the important ores of copper. The symbol of copper is Cu. The important ores are copper pyrite, copper glans, cuprite, malachite and azurite. Yes, the important ores of copper are copper pyrite, copper glans, cuprite, malachite and azurite. Copper glans. Yes, it is the sulfide ore of copper. Okay, copper glans is the sulfide ore of copper. Its formula is Cu2S. Yes, what's the formula of copper glans? Cu2S. Then copper pyrite. It is the mixture of copper sulfide and iron sulfide. Yes, copper pyrite is the mixture of copper sulfide and iron sulfide. Understand children? So the formula of copper pyrite is CuFeS2. Yes, it is also sulfide ore of copper. Understand ma'am? Yes, both copper pyrite and copper glans are the sulfide ore of copper. The formula of copper pyrite is CuFeS2, whereas the formula of copper glans is Cu2S. Then cuprite, it is the oxide ore of copper. Yes, cuprite is the oxide ore of copper. The formula of cuprite is Cu2O. The formula of cuprite is Cu2O. Then malachite. Yes, malachite is a basic copper carbonate. Yes, it is a basic copper carbonate. Here base refers cupric hydroxide, that is CuOH twice. So the formula of malachite is CuCO3 dot CuOH twice. Yes, the formula of malachite is CuCO3 dot OH twice. Then azurite. It is also a basic copper carbonate. Understand? But in chemical composition, azurite differ from malachite. So the formula of azurite is 2CuCO3 dot CuOH twice. Yes, the formula of azurite is 2CuCO3 dot CuOH twice. Understand, children? Yes. What are the important ores of copper? Copper pyrite, copper glans, cuprite, malachite and azurite. Copper pyrite CuFeS2. Copper glans Cu2S. Cuprite Cu2O. Malachite CuCO3 dot CuOH twice. Azurite 2CuCO3 dot CuOH twice. Then next we are going to see the important ores of zinc. The important ores of zinc are zinc blende, calamine, zincite. Yes, the important ores of zinc are zinc blende, calamine, zincite. Zinc blende is otherwise called as sphalerite. Yes, zinc blende is otherwise called as sphalerite. Zinc blende, it is the sulfide ore of zinc. Yes, remember children, zinc blende is the sulfide ore of zinc. So the formula is Z10S. The formula of zinc blende is Z10S. Then calamine. Calamine is the carbonate ore of zinc. Yes, calamine is the carbonate ore of zinc. So the formula of calamine is Z10CO3. What's the formula of calamine? Z10CO3. Then zincite. It is the oxide ore of zinc. Yes, zincite is the oxide ore of zinc. Understand, ma? Yes. So the formula of zincite is Z10O. The formula of zincite is Z10O. All the three ores of zinc is important. So all of you must thorough all the three ores of zinc. Yes. What are the important ores of zinc? Zinc blende Z10S. Calamine Z10CO3. Zincite Z10O. Understand, children? Yes. Then next we are going to see the important ores of lead. The important ores of lead are galena, anglesite, cerussite. Yes, what are the important ores of lead? Galena, anglesite, cerussite. The symbol of lead is Pb, you know. Okay, ma? Yes, galena. Galena is the sulfide ore of lead. Yes, remember all of you. Galena is the sulfide ore of lead. So the formula of galena is Pbs. The formula of galena ore is Pbs. Then anglesite. It is the sulfate ore of lead. Yes, anglesite is the sulfate ore of lead. So the formula of anglesite is PbSO4. The formula of anglesite is PbSO4. Then cerussite. It is the carbonate ore of lead. Yes, cerussite is the carbonate ore of lead. So the formula of cerussite is PbCO3. The formula of cerussite is PbCO3. Understand? Yes, the important ores of lead are galena, Pbs, anglesite, PbSO4, cerussite, PbCO3. All the three ores of lead are important. So all of you must thorough. Okay, the three ores of lead with the formula. Understand? Yes. Then next we are going to see the important ore of tin. The symbol of tin is Sn. Okay, the symbol Sn is derived from its Latin name Stana. You know. Yes, the important ore of tin is casterite. Yes, what is the important ore of tin? Casterite. Okay, yes, it is the oxide ore of tin. Understand? Casterite is the, yes, oxide ore of tin. Yes, it is otherwise called as tin stone. Okay, yes, it is otherwise called as tin stone. So what is the formula of tin stone? Yes, SnO2. Okay, tin stone or casterite. Okay, yes, the formula of tin stone is SnO2. Clear, ma'am? Yes, tin stone or casterite. What's the formula? SnO2. Clear? Yes. The next, ores of silver. The important ores of silver are silver glands, pyrargyrite, chlorargyrite, stephenite, prositite. Yes, the important ores of silver are silver glands, pyrargyrite, chlorargyrite, stephenite and prositite. The symbol of silver is Ag. Okay, the symbol Ag is derived from its Latin name argentum, isn't it? Yes. Now we can see the formula of all the ores. Silver glands. It is the sulfide ore of silver. It is otherwise called as argentite. Okay, yes, the another name of silver glands is argentite. It is the sulfide ore of silver. Okay, ma. The formula of silver glands is Ag2S. The formula of silver glands ore is Ag2S. Then pyrargyrite. It is the mixture of silver sulfide and antimony sulfide. Antimony, Sb. That is stibia. Okay, yes. So the formula of pyrargyrite is Ag3SbS3. Yes, what is the formula of pyrargyrite? Ag3SbS3. Then chlorargyrite. It is the chloride ore of silver. It is the chloride ore of silver. It is otherwise called as horn silver. Chlorargyrite is otherwise called as horn silver. Okay, ma? Yes. The formula of chlorargyrite is AgCl. The formula of chlorargyrite is AgCl. Children, the another name of chlorargyrite is horn silver. Similarly, pyrargyrite. Pyrargyrite. Okay. The another name of pyrargyrite ore is ruby silver. Okay, pyrargyrite or ruby silver. Formula is Ag3SbS3. The formula of chlorargyrite is AgCl. Okay, ma? Yes. Then stephenite. Yes, it is the mixture of silver sulfide and antimony sulfide. The formula of stephenite is Ag5SbS4. Yes, the formula of stephenite is Ag5SbS4. Then prositite. Yes, it is the mixture of silver sulfide and arsenic sulfide. Yes, it is the mixture of silver sulfide and arsenic sulfide. Okay, yes, the formula of prositite ore is Ag3AsS3. Okay, ma? Yes, the formula of prositite ore is Ag3AsS3. Yes, study thoroughly all the ores of silver. Once again, we can see the importance ores of silver. Silver glands, Ag2S. Pyrargyrite, Ag3SbS3. Chlorargyrite, AgCl. Stephenite, Ag5SbS4. Prositite, Ag3AsS3. Children, that's all about the important ores of metals. So all of you must thorough the important ores of the metals. Understand?